Hello everyone, my name is Romi Kumar and today we are going to learn about KMP algorithm. It is used for string matching algorithm. It is more efficient than the other algorithms. Efficient string matching pattern programs how to search pattern inside a text in a linear time without ever moving backwards through the text. We don't need backward. Don't want to go backwards. What we will cover? The problem statement, the key idea, the LPS array, the search phase, Python implementation, and the complexity and its uses. Let's see the problem. Slide over the text on one position at a time, comparing the whole pattern. Every mismatch throws away work done already. Like there is a text A, B, A, B, A, B, C, A, and we want to match A, B, and A, C. But we have AB and AB at the first attempt. The attempt will be lost. Then we'll move to the next array, and through which we don't need to go backtracking method, and we'll be moving forward and matching the strings one by one. The key idea is to never look back. Even a mismatch happens, a character already matched tells us exactly how far we can safely slide in the patterns without rechecking any of them. The main aim of this algorithm is not to do any backtracking. We want to move front and we don't want to see backwards. If the matched parts repeat a prefix of the pattern, the repeated prefix is already known to match. So instead of restarting comparison from the scratch, KMP resumes just after the prefix. We have to see the prefix and suffix clearly here. If there is a mismatch, we don't need to go to the start from the scratch we want to start, but we can start from the where we have the problems is there. We want to move forward and not to look back. Naive. One mismatch moves the pattern one step right. Compare from its every first character again. It means that if we have one mismatch, we are one step closer to the goal. We don't need to go back. Building LPS array. For pattern P, A, B, A, B, C, LPS I holds the length of the longest proper prefix of P of 0 to I, that is also a suffix of it. Index 0, 1 to 4, a pattern A, B, A, B, C, LPS value 0, 0, 1 to 0. It means the number of times it has been repeated. I is equals to 0, P of 2, A matches to the P of 0, A is to the prefix A is also a suffix here, and by which we want to move forward and not to do any backtracking. The search phase. Two pointers scan once through the text. I tracks the text, J tracks the pattern. One mismatch, J jumps back to the LPS array. I never moves backwards. It means if the I is staying at the starting of it and the J is at the end of the end of the pattern. If the I is matching, J is mismatching, I will be moved forward and it will never go backwards. Note, the two already matched characters AB don't need to recomparison. They are guaranteed to match because they equal the pattern's own prefix. Scanning continues immediately from the new positions. Here is the algorithm. Length 0, LPS 0, I is equals to 1. While I is greater than M, if P of I is equals to P of length, length is passed to the length plus 1. It means the if the P of I is equals to the P of length, the length value will be plus added to the another one. The next one, scan the text. I is equals to 0, J is equals to 0, while I is greater than N. Sorry, my bad. I is lesser than N. If P of I is equals to P of J, I will be transferred to I plus 1, J will be transferred to J plus 1. It means it will be moved forward. And here in the algorithm, you can see there is no backtracking method ever mentioned here. Here is the full Python implementation. Simple run and complexity. It is one of the easiest pattern matching, string matching pattern algorithm we can use. where KMP is used. KMP is used in many ways: text editors and search engines, bioinformatics, illustration detection, plagiarism detection, compilers. In text editors, finding or replacing the large to replace in a large documents. Like if you have 100 pages of PDF and you have to search a particular word, the KMP will use to find that particular word within no time. Search engines, you can see in Google search engines, it will show the similar words which you have been searching. Bioinformatics, finding gen or protein subsequences of DNA strings. Illustration detections, matching known attack signatures in network traffics. Plagiarism, locating copied phrases across a large crop. Like if you are writing a research paper and if you're using the same phrases that are used in other research, it will detect the plagiarism easily. Compilers, tokens and keywords recognition during the lexical scanning. Thank you.